The average life, and I don't know, really, this is probably debatable, the specifics of this, but the things that I was reading, the average life expectancy in Brazil was 5 years. 5 years after the rifle. That was the average life expectancy. And the average life expectancy in Jamaica, as the British and the French expanded their sugar production, was 7 years. And again, I'm sure that there's lots of, I'm sure that careers are made on by nesting those numbers, but that's about right. That's what the sculpture's about. And let's just take a look at how this was portrayed. So this is also about, we can also see how the sugar production was carried out. So basically what you have to do is harvest the cane, you crush it, that's a key step. You bring the crushed cane and the fluid to boilers where it's refined, and then I don't know what's exactly happening here because it looks like they're storing the liquid. Often this was molasses or some sort of syrup, but it was also then later, of course, crystallized and all kinds of stuff about production. And by the way, the book that we'll be reading a lot about sugar, but one classic is called Sweetness and Power from about 30 years ago. Is one thing we'll be reading. And one thing I think is really striking about this picture is it doesn't look too bad. It looks okay, you know. And if we look at this picture, it looks downright idyllic. It's not so bad. And so I talked about deconstructing some of this imagery. Well, obviously this stuff is just made for the consumers of sugar, Europeans and Americans, white Europeans, white Americans, to feel like it's great. Sugar's awesome. In fact, this I got from the 1619 Project, an article in the New York Times published a special edition of their magazine last fall on the 400th anniversary of slavery in this country. And this is appalling. Sheet music to an 1875 song romanticizing the painful, exhausted death of an enslaved sugar plantation worker. That's crazy. That's absolutely crazy. Yeah, here we are. So that's what this is a response to. And I think that's suddenly where it begins to make more sense. If we understand it in that context, this is the only real possible response. And then, of course, there's more. Being sugar, one thing is that as sugar production began to increase, it became, of course, more consumed. So by 1850, say, in Britain, the average sugar consumption was 40 times what it had been just a century before. And of course, it's been going up ever since. And let me just catch up to what I wanted to say about that. In fact, and this is kind of remarkable, that by 1900, in Britain at least, just to take that example, sugar was already a quarter of the calories consumed. And that's still often the way. So it's kind of strange. If you have a working class like poor people, as sugar production became mechanized and expanded, it actually became a good way to keep people alive. So Linda mentioned that we lived in Mexico for a year. We happened to be there during a year when there was this campaign to put a tax on the soft drinks, and it was defeated. And I think later there was a tax on the soft drinks. But the real argument about not taxing the soft drinks was, like Coca-Cola and so on, was that it was a very important source of calories and clean water for a large number of very poor people. Which is crazy, right? But really the thing, it's a real part of what was going on. It was going on in Britain 100 years ago and all over the developed world, and all over the world, period. And we are familiar with that. But it's, of course, in everything. And this is an interesting thing. This, by the way, I should say, was all over I found the same graph all over the internet, and I finally tracked it down to its source. And it's not necessarily clear how reliable this is. There's some things about the methodology. But I did find the source. And this shows sugar consumption in the United States over the last 180 years. And you can see, it's kind of neat, you can see World War II, right? You can see the Civil War. It's right there to see. But basically it's a trend upline. And then we had a little bit of a thing where, obesity became more discussed and sugar consumption and all the detriments of it became more of a thing. But the real point of this was pretty neat. The guy that did this, Stephen, was actually kind of joking around. He was pointing out that if you do linear regression on this, by the year 2606, our diet would be 100% sugar. So I thought that was cute. But I guess the good side of that is it means that that's the percentage of our diet now. It's about 15% typically on average, which is not too bad, I guess. The World Health Organization says it should be 5%, which is, it turns out 5% of our calories from sugar, it's 4 calories a gram. It turns out it's about, I guess that's an ounce. No, 2 ounces, something like that. So 4 tablespoons, quarter cup, something along those lines to be right now. No, it must be whatever. We'll work it out later. So that's sugar, and that's a bit heavy, but that's sort of the idea of moving something around throughout history and sort of examining how history can be filtered through this. And this is kind of, as she said, a popular style of thing. There's several books along these lines. Mark Kalinsky got this all started, or at least was an early one in with a lot of stuff. Now he's made a whole industry,
world history.
Kind of stuff. Like looking at history through cod or salt or paper, unobvious things. But I'd like to take a few minutes just to play a little game, which is to just pick some items and try to think about, okay, like let's just try to look at world history or look at humanity or the way that we could discuss reality through a few little things. And I actually have the slides sort of in order, so it'd be more fun, I guess, if I could just have you call them out and get picked. But but I'd have to sort of fumble through the slides to make that work. But really, these are all things that I took. These are all photos I took, for the most part, of little things that we might discuss what this is. So let's start with this one. This one's a good one. This is coffee beans, and we'll definitely be talking about coffee. And you probably know a lot about coffee. Probably most of your consumers about coffee. But one of the most amazing things about coffee, I'm going to pick like one little thing here, is that some people, whether it's exaggerated or it's can be not, but to some extent, well, one thing that's for sure is that most people in Europe were drunk until the introduction of coffee. Drunk from the time they got up to the time they went to bed. And the reason is really simple, that nobody in Europe, it wasn't popular to boil water. In China, it was popular to boil water. And so sanitation is a big deal. And one way to have sanitary water is you put alcohol in it. And to be sure, it was, often diluted in many places, but like if you read there's this there's like direct historical accounts of the shopkeepers selling this much booze to this many people. So there's a tremendous amount of booze, like 10 liters of wine and stuff, like staggering amounts of booze was being consumed. And so one thing is that coffee in some sense is credited not just because of its stimulating properties, but just to get people to have a different state of mind with having some role in the scientific revolution, with the entrepreneurial revolution, with the Enlightenment. Now, I'm sure that can be debated. I'm sure that's endlessly debated. But one thing for sure is boiling water was a big deal, and boiling water, coffee was a reason to boil water. So that's neat. Or this one. This is another sort of 17th century kind of thing. The die. So dice have been around for thousands of years, and gambling has been around for thousands of years. Games of chance and drawing lots are mentioned in the Bible and elsewhere. And oracle bones in China were perhaps, they're not dice exactly, but they had something to do with the development of Chinese lithographic writing. But I mean something specific here which I'd like to explore, which is simply that risk analysis, understanding risk in a scientific and mathematical way is central to our modern society. It underlies insurance and statistics. Statistics is critical for lots and lots of science, lots of other things. Insurance is critical for having an economy where people can take risks and have some spread out the risk, and all sorts have instruments, financial instruments to do that. And yet, all of this really does hinge on the die, because basically all the mathematical foundation of this, in the 17th century, the way a mathematician could live would be to have a rich patron. And the way that the mathematicians who were developing the science of risk, their rich patrons were interested in gambling. Yeah, so that's cool. Or this one, we're going to do, I don't know how, honestly, this one is, I don't know what the academic reputation of guns, germs, and steel is. I'm sure that a lot of people say that it's overly broad and too simplistic. And
Indeed.
I'm sure of all that. So we'll definitely.
I'll come find you when
The responsible thing to do is, but I'm going to tell you the thesis. We're going to read some of Guns, Germs, and Steel, and we'll, to make it fair, we're going to read the criticisms too. Okay, we're going to definitely do that. Because I know. But one thing that Guns, Germs, and Steel discusses was this very contentious thing. He basically said that all world history essentially could be described in this way, which I think is clearly absurd. But one thing that does seem interesting is that where certain grains happen to be growing wild was important. Why did domesticated, say, work animals, why were they in the Old World but not the New World? Well, there weren't any suitable species, at least by the time we got rid of killing them all off. And so, the lentil, of course, the Neolithic Revolution, the agricultural revolution is critically important, but also there's these accidents of history I'd like to just sort of, we'll take some time to talk about. We'll talk about it in a limited, I'm not going to go as far as, we'll do it in doses. And then of course soap. One thing that's interesting about soap is that when Europeans showed up in North America en masse, there's this trope of the indigenous peoples were barbarians. Actually, they thought the Europeans were barbarians, of course, because none of the Europeans, the indigenous peoples by and large valued cleanliness a lot, and none of the Europeans did. Many of the Europeans had never taken a bath in their entire lives. So the history of soap and cleanliness is something we can touch on, and this just goes on and on. Oh, this is a really useful, tremendously useful object, but we're drowning in this stuff. This is a reputable statistic, a reputable claim that in 2050, in my life, the end of my lifetime, there'll be more plastic than fish in the ocean. We're doing something really horrible, and we are not paying attention. So there's a whole book on that, and it just kind of goes on. I want to let's close with this. So this here is a mere wrench, but this sort of, I think, this is emblematic of basically what I'm really trying to get at. What is the technological pedigree of a tool like this? Of course, there's all the metallurgy and the design work, and there's all of this stuff that we could discuss. But one thing that I think is really compelling to think about is that every metal object was made by metal objects. So where did those metal objects come from? Every metal object has its own ancestry of metal objects, of metal tools. Ultimately, all metal objects have this pedigree of basically that goes back to somebody somehow figuring out how to take a chunk of iron ore and make it into something without any other metal tools, right? And then once you get it started, it sort of becomes okay. But there's this whole tremendous history of metalwork, which is really quite astonishing and quite worth thinking about. You need the tools to make the tools, to make the tools, to make the tools, to make the tools. And that's where I think I'll choose to stop.
All right. Woo-hoo! Professor Goodman-Strauss is happy to take questions.
Sure am.
So I'm going to let him vet.
Including about the courses, the mechanics of the courses.
That's actually what I wanted to ask. So it sounds like there's a lot of reading, and then what are the
so let me show you. It's a very different style of course than I've ever taught, obviously, and I know that humanities students take seminars and so on. So I'm a bit of an amateur in that regard as well. But what I'd like to do is we will have readings for the first several weeks, first 8 weeks, first 2/3 of the semester. We'll have readings every week, and then every student will talk about the questions. And then, but for the second half of the course, what I think is much more interesting, really, is to have every student who is in the course actually think about a little object that changed the world, in whatever mode this might be, and propose that. And then this has to happen in good time. So then do some research, come up with readings, and then those readings are in turn assigned to the class. So that people can react to it, and then we'll have a discussion. And then finally write a paper. So from the student perspective, basically the assignment is do the reading and become prepared to at least have some thoughtful comments for the first 2/3. And then in the second part of it, expect that one day you're more or less going to drive the class, that you're going to choose some topic and choose the readings for it. Not a lot, just something to read. And then everybody else will be responsible for reading that. And then finally, write a paper, but in the context of having the reaction, having had a class discussion and critique of the ideas, so that the paper itself will have been more as much a summary of what's happened in the class, what the class discussion was. I'm sure that will inform a lot of that. And that's it. But mainly, another part of it is it's not going to be lecture. It really isn't. Like Trish Stark's class, I really hope to have it be mostly discussion. I'm not going to do this at all. This is not happening. So, plus just getting all these slides together. I think it'll be a lot of fun. So let me also just say this. I'd like to do take more questions. But I want to do this exercise.
You're in charge, so go for it.
I want you all to do this right now with me. I want you just to simply put out your hand on something right now. Just write onto something. Yeah, the back of the chair, anything. It doesn't even matter. Your shirt, your neighbor's head. And just reflect for a moment what it took to get to the point where that thing could be manufactured. I mean, how many people, how many minds were involved in the development of that thing, that technology? And once you start thinking that way, it's impossible to see anything but this massive communal exercise that we've been on for tens of thousands of years. I mean, it's humbling. It's absolutely mind-blowingly humbling. You are touching, literally within arm's reach, even forgetting stuff like these electronic things, which you think are really fancy and sophisticated. You are touching the product of literally millions and millions of minds. That's not a joke. That's not even remotely an exaggeration. If anything, it's understating the case. Any one of those things evolved through time and refinement. And any claim, the illusion is that we exist as individuals in separation from other humans, that our groups exist in separation from other groups of humans. That's nonsense. It's absolute nonsense. And when you look at it, the world from that perspective. And that's ultimately what I really hope to share that sense with you all now, but also through this course. So, and I really will take any questions, but
Yeah. Come on, mathematicians.
Yeah. Is there a particular item that you've looked into that surprised you?
They all
just, well, I was going to say the most, but like you have
well,
this stuff that there was a real turn.
I think the whole string thing is just like crazy.
Good
That's
mathematical
great.
choice. Yeah.
The whole series. It's not string theory. It's just.
I know it.
The fiber arts are really amazing. Very deep.
How about the wheel?
I kind of forgot to do those things. Yeah, I mean, obviously the wheel's important, and we can talk about all of that. And well, part of it, and obviously we could do that, right? But the conceit is to sort of like, let's make it more difficult, you know. But obviously, the wheel, sure. But the New World got pretty far without wheels for mechanical work. But we will do things, so like for the wheel, we'll reduce it to maybe like gears. Let's talk about gear work. Let's talk about little gears. Big gears.
Question.
Yeah, one of the things that's kind of never officially, but always in the back of my mind is what I've thought of as inventions that haven't changed a lot over time. So like things that seem to be like irreducibly complex, or.
But I don't think.
And that's what I was going to ask you now. So in my mind, and I'm starting to see how far off I might be in some of these things, but I think of something like various instruments, for example.
Right.
That in my opinion, it's not really an opinion, it's just my thought, is they probably existed in a very similar way for a very long time.
Most instruments, maybe the core idea has.
Right, or like, and so I would have said a needle, but you're sort of showing how no, needles are like highly evolved even up to today.
Since I have the excuse of doing this, let me show you something really. Oops, sorry. Hope I did. this Paleolithic flute. I mean, this is, again, just astonishing. There are flutes that are pretty good, and I have an image of one that are 45,000 years old. And not only are they 45,000 years old, the slide I prepared it's clear, it has a fifth. It has a well-defined fifth on it. You can play two notes, at least two notes, two that are survived within a fifth. But nonetheless, isn't it amazing? 45,000 years ago, somebody was playing a fifth, at least as much. And that, but then on the other hand, clearly there's been all kinds of refinement since, even through any kind of flute you might want to play. I don't know that there are any irreducibly simple. I don't know. I mean, if somebody can bring me one, clearly there's ideas like the wheel or the flute or the needle, but that have some Platonic essence. But in terms of the actual mechanical rendering, and that reminds me of another book that we'll read at least a part of, called The Evolution of Useful Things. It has a whole page on, it has a whole amazing page on 30 different kinds of forks. And so it kind of points out maybe, it certainly discusses that directly. Well, do you have any
Do you have a
further?
question over here?
Oh, sorry. Yes.
I guess having made a number of tools in my lifetime, kind of thinking of the technology behind it, and just kind of some of the things that you brought up. One of them was your rope maker,
Yeah.
and you were saying two of the holes, the grooves look like the rope was twisted one way
Yeah.
for two of the strands, and the other way for the other.
Right.
Modern rope is not made that all three strands are twisted.
Oh,
the
they're
same
twisted
way.
the same way. That was my mistake. I thought they were twisted in opposite ways.
No, they're all three twisted one direction, but then then the rope is twisted the opposite direction
From the
of
strand.
the three strands.
that's
The
what
three
I was
strands are all one direction.
Well, see, again,
and the rope is the other direction.
Yeah.
And so, it raises that question of that tool obviously looks like it was made to twist one the other direction, and just, I can't imagine in my mind enough to say, it seems like it would kink it up.
Well, maybe it did. Maybe that was the crummy experiment, and then
Yeah.
figured it out.
And maybe they threw that rope maker on the junk pile, and it survived
Might well.
because somebody cut the grooves the wrong way.
That might well
there's a
We
lot
have
of
no
things
idea,
that,
of course.
and a lot of those things are really old. I guess I have a friend who has made a million more tools than anybody else I know, that asked me once years ago, did the inventor of vice grips, is he sitting back fat and happy, or are you kicking himself for having sold out for so cheap? Because it's such a wonderful tool, and now that there's Google, I could look it up, but I hadn't thought about it for years until you had put it up, and it's something that's recent enough that somebody probably has it documented, but
Perhaps.
there's
Well,
the whole thing raises questions on every slide.
The whole thing about manufacturing tools, I want to just think about this. How do you manufacture a straight ruler? Not a ruler, but just a straight edge. You probably know. Like if you have two boards, how do you make sure that they tend to work? How do you make them straight? If you don't have any other tools, there is a way. You just simply rub one against, do some abrasion thing, right?
Well, there's a plane.
Well, if you don't have a plane, right?
Yeah.
But
Yeah,
there's sort of, you have to
before
leverage
a
your way
plane,
out.
there was an ads that was, relatively rough hewn.
Right. So all of this stuff is built upon everything else.
And there were stone adzes before there were metal ones.
Right.
To be able to shape boards by hand.
Absolutely.
All right, let's
Thank
give
you.
our awesome mathematician a big round.
Some of you this fall.
And I'm sure that Professor Goodman-Strauss will answer individual questions that you might have, but that was amazing.
Thank you.
Good job.